the EV manufacturers are actually shooting themselves in the foot if they were to procure nickel from.
In case you missed part 1 of this interview, that video will be linked in the description. We talked a lot about Tesla's role in the nickel industry and what Tesla needs to do to make Master Plan Part 3 a reality. This video is a continuation of that conversation. Today we'll hear from John Lee, the CEO of FLYN Nickel Mining Corp, who's also a chartered financial analyst. He's spent the last 20 years in the mining industry and has raised over $150 million for mining exploration. He's also owned several Canadian nickel projects since 2009. You guys know I don't ask for early likes, but today I'm going to. So before you forget, please drop a like below to thank John for taking the time and to ensure we can keep bringing on great guests for exclusive insight. Nickel is critical to the future of the semi, the Cybertruck, and the Roadster, and of course, 4680 production for the foreseeable future. The timestamps will be below. Enjoy. All right, John. So to start, can you give us an overview of the different types of nickel ore deposits, laterite versus sulphide, and then maybe a little bit on the different grades, class 1 and so on, that make up the global nickel market?
Yes. Well, Dylan, there's only one nickel in the periodic table, but the nickel exists in different forms on Earth. It's quite an abundant metal. It's, I think, the 5th most common metals on Earth. But the nickel is known to be notoriously difficult to extract. So, for example, typically in today's world, there's on average about 1% nickel that sit in the mineral reserve, or what they call the ore that can be extracted. So think about a percent of nickel. That means a metric ton of ore. You'll have maybe 10 kilos of nickel. So 1% is a very small, tiny percentage. And the way they classify nickel, majority of the nickel resides in either what they call the laterite or they call the sulphide. So laterite is another name for oxide. Really, the difference, I think, to sort of putting in layman's term, if you think of a nickel as the nuts, right, for your Snickers bar. So the laterite you can think of as nickel in the Snickers bar, where the nuts are very glued with the chocolates and with the caramels and all that stuff. Whereas the sulphide, you can think of the nuts maybe as the toppings in the ice cream. So typically sulphide is a lot easier to process, whereas oxide is a lot more bonded to the other minerals and waste and silica and clay. And that is a lot more difficult to process. So up till about 10 years ago, around 2010, majority, I would say 90% of the nickel came from nickel sulphide. And the process, really quick to go through how nickel is mined and processed, is typically, you dig the ore out of the ground. So every ton of the stuff you dig, the rock, has 10 kilos of nickel. So you will grind it to as fine as sesames. And then from their point, you will apply reagents to separate the nickel from the other impurities. And from there, you upgrade your nickel from 1% to 20%. So it's all about, Dylan, from how can you get from 1% concentration to up to 99.5%, which is required for the commoditized nickel trading. So just work from the 20% concentrate, which you produce on site. So that would be like a milkshake type of a form of product that contains about 20% nickel. From there, you go to the smelter. So the job of a smelter is to basically put that nickel in a furnace to burn away the excess, depending on the melting points. So you'll get to the nickel intermediate at around 80% nickel. That's nickel matte. And for nickel matte of 80% nickel, then we go to the refinery, which is a sophisticated version of the nickel smelter. But again, it's a pyro technology of a furnace. And then you will further refine that nickel up to the standard level of 99.8%. So when you get to that level of purity, which is then can be traded on the commoditized exchange, like the London Metals Exchange, that's the largest metals exchange, that is then in the form of what you call the class 1 nickel. So when you talk about class 1 nickel, that specific refers to the purity of nickel. Typically, has enough of meeting the specification to be traded on the London Metals Exchange. Dylan.
That 90% of the ore that's mined that doesn't actually go to producing nickel, is that put back in the ground, or what do they do with that after the fact?
Right. What they do is they will dig a pit. So imagine the pit that you dig to get the ore out of the ground. The pit that you dig to store what they call the tailings, which is the waste, is sometimes 5 to 10 times bigger. Because remember that it's more than what you just dig out of the ground, because you actually had applied some reagents to separate what you wanted. And so usually they will have to dig what they have to create a tailings facility. And the tailings facility ideally is if you have some natural occurred valley or some sort of a valley, or you have say a cave, then that would be quite ideal. So then what you do is you actually will lay the linens, so which would be synthetic, of which you would prevent the spill of what they call the tailings, and then that tailing is monitored 24/7.
Okay. So I've read that around 65% of the nickel used in the Western world is actually for stainless steel. So my question is it true that most of the nickel being used for EV batteries is only coming from the sulphide deposits and not the laterite?
Dylan, you're right that if you look at the pie chart of the usage of nickel, majority, over 50% is used as stainless steel. And that is for your, it has anti-corrosive properties. It has that shining feature. So if you look at all the utensils and a lot of the piping for construction and a lot of the different alloys. So nickel is about 3 times the price of copper. So it's pretty expensive metal. It's about 10 times more expensive than aluminum. So there's a lot of times when you will mix alloy to take advantage of the nickel, to take the nickel features and characteristics. And it's also very ductile. So typically, if you look at utensils, you're getting up to 30% in nickel content. Now, regarding the nickel used for batteries, there is no difference well, nickel used in batteries such as Tesla's battery, lithium batteries. You have the lithium that's actually storing the charges, and you have the anode and the cathode. Anode is typically graphite, and the cathode technology is advanced a lot to the highest performance batteries. You have about 80% nickel and 10% manganese and cobalt. But that 80% nickel, it doesn't really matter where the nickel is coming from, either the laterite or is coming from the sulphide, as long as that nickel has high enough of a purity. And because, as you know, the EV batteries, they're very volatile. So the chemistry has to be right. A lot of the times that the nickel goes into the batteries, they could have specifications of not have other impurities exceeding 0. Whatever percentages. So typically, you say that nickel coming from sulfide has less impurities than the coming from laterite. However, if you look into produce the batteries coming from the 99 class 1 nickel, then typically you will not have a problem. The problem usually comes, Dylan, is a lot of the companies, they were trying to make shortcuts because the nickel in batteries, they're not 99.8% purity, they're nickel sulfate. So there is a processing to produce the nickel required for batteries. So sometimes you have manufacturers that will try to say, why do I want to go up to 99.8% and then produce another intermediary product for the battery? So sometimes they may make shortcuts from directly during the processing of laterite or through sulfide to try to not go through all the way to the class 1, but divert that process to producing nickel sulfate. It's a lot easier for nickel sulfide because it's coming from the sulfide family. It's a lot more difficult to do that for laterite, even though a lot of companies try. So if you get to the 99.6% nickel, the battery manufacturer doesn't really care the origin of where the nickel came from. It is nickel of that purity they wanted. From there, they proceed to produce the nickel sulfate required for their batteries. The only difference comes, Dylan, that because the processing for nickel sulfide is very, very different from nickel laterite. In the energy input, so for example, in nickel laterite, they have to use, they call it HPAL, which is high pressure leaching process. So you're subjecting your ore to a very highly concentrated acid, and up to 50 times bar, which is 50 times the atmospheric pressure, and temperature up to 300 Celsius. Because you remember the example I talked about earlier, that you're trying to get the nuts out of the Snickers bar, right? It's a lot more difficult, say, coming from the ice cream. So I would just say that for example, and especially I think today, people pay a lot of attention on what they call the carbon footprint. You have a lot of different companies, anywhere from mining to manufacturing to oil producers. They're saying we're going to be carbon neutral, which means that the carbon that comes, they have to find someone to balance their carbon footprint. So in the case of nickel laterite coming from Indonesia, that's very energy intensive laterite, regardless of where it come from. But the power is coming from coal-fired power plants. Whereas, for example, the nickel sulphide coming from, say, Manitoba, Thompson, Manitoba in Canada, where our mining project sits, the power is 90% hydro-powered, and we don't need any pyro or furnace or heating to produce that first stage of the 20% concentrate. So the carbon footprint could be a difference up to 98%. And the way I look at it with the ESG, a lot of the ESG talks, environmental, social, and governance, I believe before long, for every product you buy, Dylan, including Tesla or your Apple phone, you're going to have what I call the nutritional table, which means that you're going to see the product of origin, and that origin may be split into, not just the end product manufactured, but the sub-ingredients that make up your product, and as well as your carbon footprint. So you could have a per unit of carbon and the amount of carbon emission that goes into that. And there's a lot of different countries, I think Sweden or Denmark, that have detected the highest carbon penalties. And for mining companies or for auto manufacturers, if they rely on ingredients that have a very high carbon intensity, which is not avoidable, then they have to somehow either buy carbon credits from the people that produce carbon credits that balance them out, or they have to buy other ingredients that have very low carbon footprints. So either way, these are not just feeling good scenarios, that there's actually very concrete bottom lines associated with buying nickel that's got 20 times or 40 times or 50 times more carbon footprints than buying nickel that's got lower carbon footprint. In fact, I think, Dylan, I just read the news, a lot of the environmentalists actually sent joint letter to Tesla to ask them to stop buying nickel from Indonesia, because that Indonesia nickel coming exclusively from nickel laterites. And not to mention, there is a lot of environmental hazard, because if you apply very high concentration of acid to dissolve your nickel, and for example, for our mine, we don't use any acid at all, then the tailing, which is the disposal of the waste, is going to be very, very problematic, because they could, and right now in Indonesia, they resort to dumping that tailing into the ocean. So that is a very contentious subject to have to deal with.
Yeah, that is a perfect segue, actually. So earlier this year, Biden actually canceled some mining leases in part of Minnesota. Now, of course, the argument is that they want to protect the boundary waters, and I'm all for supporting the environment. However, my question for you is, are the fears of this environmental disaster, if there were nickel mines around that area, are those legit, or are those somewhat overblown?
Dylan, I think the technology had advanced a lot, especially in the last 30 years. I mean, if you just look at the phone that you take a picture with versus the Motorola Razr, right? You took it 5 years ago, that was the latest and greatest, you see the definitive differences. Same apply especially for monitoring technology for mines. So there's a lot of monitoring, auditing technology to avoid accidents. Regarding issues on the Minnesota, it's Kathleen, around the Duluth mining complex, which we actually studied in the past. I would say this, Dylan, permitting a mine is getting increasingly difficult, and it's really there's a lot you got to build. I would say you got to go from the bottom up and the top down. So what I mean by that, you have to get the buy-ins from the local communities, from the district, from the state, from then all the way to the federal level. And any one of them will have veto power, as you see in the case of Duluth complex. They're close to watersheds. Of course, that will raise logically a lot of concerns. And then I would say that, in general, I would just say, Dylan, that to permit a mine, you really got to have, like I said, buying from all levels of stakeholders. And also that it's not simply a matter of law, but it really takes three pillars. Is taking the law, which usually is quite clearly stated, especially in Western world, but it also takes logic. Okay, so you can reasonably understand that if you are close to some major water source, or if you're in a community of which they have no precedence of mining, if you have some communities that are already infighting, such we have projects in Bolivia that has infightings amongst themselves. It's very difficult for you as an outsider to come in and establish consensus. So depending on the local levels of their familiarity of mining, that's where the logic comes in. And like for example, in our mine in Manitoba, we have an agreement with the First Nations locals where their participation is actually tied to the price of nickel, right? So I think there's a lot of little things there. Besides law, I think that's where a lot of companies got hung up. They said, well, the law allows us to build it. We've done everything by the book. Why are we not getting permitted? And you got to have that logic. And then the last point is you got to build that relationship. So the way to build relationships, you gotta get them have participations in the process. It could be as important as where you want to build the factories, or but too much load is how you want the color or the logo to be, so that they have that buy-in. And the reason it's important, Dylan, is because mining is a complex subject that there's always going to be issues that come up constantly. So in order to gain their confidence in having that mutual objective and to make them understand what mining is about, because you're talking about an enterprise that can go on for 10, 20, or 30 years. And it has a lot of different variables associated. A lot of times people are put to different layers of interpretation. That element of relationship is also very, very critical, because remember again, you could be a multinational going into an area that have never seen a mine in the last 20, 30 years. And then you're proposing dig a hole that could be 150 floor deep, and an operation that could cost billions of dollars, and all these heavy machineries of which they might never seen before. So I think tying back to the Minnesota, I think it's more that meets the eye. This is a very complex subject. And I would say that if people don't really care about mining, or for auto manufacturers, for example, or battery manufacturers looking to invest in the mine, or such as yourself doing due diligence, you got to go to the mine and visit it and insist on talking to the local community and the state representatives to get their feel for it. And if the companies haven't done enough homework on those fronts, typically that's why you're running into a lot of the problems, Dylan.
So has there been any progress in potentially shortening this permitting process, from whatever 5 to 10 years down? Or even with the expected increase in demand and the importance of nickel, is it just going to stay what it is? It's going to take 5 to 10 years for the next 30 years.
There is being a lot. I mean, since the Trump administration, they classified over, I think, 33 metals as critical minerals. You have a lot of metals like nickel, vanadium, rare earth, where majority, over 80% of these metals are produced in what the U.S. termed adversarial countries like Russia, or geopolitical unstable country, South Africa, and in China. So under the Trump administration, they actually passed a secretarial order from the Interior of which is the legal arm of the United States, what they call the 3355. So that was supposed to mandate all permitting process from the day you file the application, which is called the environmental impact statement, that the government has to adjudicate and issue a decision within 12 months. And and then during the Biden administration, they further included additional metals such as nickel into the fold. It's easier said than done, Dylan, because we have also mines in the United States who try to permit. You're looking at a process that's been established for over 200-300 years, and of which there's a lot of different. Think of a refrigerator. You stick a lot of things in there, and none of them got taken out. So, and then you have a lot of precedents and cases in lawsuits or in regulations passing different jurisdictions, of which they are not certain whether they're applicable to any particular project. So when you, like for a company like ours, when you prepare an EIS in the United States, or what they call the environmental act license in Canada, your applications is in the thousands, if not tens of thousands of pages, because you have to address all the potential issues, what they call the risk mitigations, in those documents so the government can review and not produce rebuttals. So while I think long answer short, under the previous administration, they provide that directive, but it was very difficult to enforce. I don't think any mine actually got past that 12 months because it was impossible to. And then they said that it has to be reduced to 100, no more than 150 pages, and it's supposed to be relevant and not encyclopedic, but that was not possible. What ended up for us in our case, we literally had to put the addendum of thousands of pages in the appendix. Under the Biden administration, that they criticize, and I think that under critical metal, you're sort of escalated to under your review process, but that review process still, there's no clear guidelines on which part of the refrigerator we can discard. So which means that the actual application are still very much very, very voluminous. And I think, Dylan, that's understandable because as we're deeply involved, we have 3 different mines undergoing this process, and it's taken just the permitting, I would say minimum 3 years. And if there's challenges from the First Nations or state or community level or the EPA, then it could go on for a decade or more. And so these studies, so just give you an idea, will include fisheries, water, air monitoring, noise monitoring, local habitats like birds, horses, eagles, bats, and archaeological studies. If you discover, say, a bone, you have to carbon date how far they go and the importance of that, and then you have to produce a mitigation plan. So I think Biden critical, I think you're going to get a lot more attention, but in terms of the process of getting that permit through, would also depend a lot, remember, on the local support, because in the end, if the more stakeholders get involved to put pressure through the statesmen from the Congress, from the Senate, I think the more representatives that we can rally to push the cause, the faster you can get that. But of course, if you look at the case in Minnesota, if you don't have local buy-ins and the local press are writing negative about it, that just give an additional sort of armor for the opponents to veto your project at the higher level.
Right. Do you think that nickel players, specifically miners and some refiners, are purposefully moving slowly to keep the supply down and the prices up?
Well, that there is difference between refiners and miners. Right now, the refineries and smelters, remember, you go from producing a concentrate, which is around 20% of the nickel content, then you go to the burning that get to the metals. Smelter and refinery, I don't think they're operating more than 70% capacity. The reason is there has not been enough nickel sulphide feed coming out of the ground for the last 10 years. As I mentioned before, Dylan, the laterite production scheme is very, very different. It's very high acid and high temperature. So these are plants that are almost dedicated in Indonesia, Caledonia, Madagascar, and Philippines. So the refineries are referring to like the ones the United States want to build, or trying to subsidize. I don't think you're going to get customers because there's oversupply of refining and smelting capacity. So I think what is needed is clear the hurdle on the permitting, or streamline or establish a more transparent process, and have active engagement, maybe encouragement from the federal level to encourage the state to make that a priority.
I know earlier you touched on like innovation, and so I'm wondering what that innovation looks like in the mining or refining space. Is it pretty much the technology is what it is? There's not a lot changing, or even over the last decade in terms of, lower pollution, greener mining, greener refining, is there a lot of progress being made? Are there any breakthroughs on the horizon? Like, what can you tell us about that?
Yeah, again, I want to separate, Dylan, a sulphide from laterite. I mean, laterite, you're literally burning your ore from 1% to 80 or 90%. Whereas sulphide, there's process you can segregate the nickel content from the waste without having to burn them. And that's why, as I mentioned to you, ice cream example versus Snickers. Ice cream, you're much easier to get the nut out of the rest. The technology is fairly mature. There's not a lot of breakthrough. I think the breakthrough is in the recovery, maybe from, of the 1% nickel in the ground, only 60 to 7% of that is recoverable. So if you're talking about 10 kilo out of a ton, you're only recovering about 6 kilos of that. So there is some room to improve that, but it's not that much. The other area I would say is in the emission reduction technology that, you used to have a lot of the dirty smelters and refineries being shut down in Canada. And, there's a lot of filtering and catalysts and to make sure that you meet emission standards. Outside of that, it's a struggle. That's why I think this in the nickel market, you're not going to see, some new technologies that will come that will fasten the production of nickel. I think that would be a big challenge.
Okay. And then as an investor, someone that likes Tesla, supporting, sustainable energy, protecting the environment as best we can, should we want more supply to come from sulphide or laterite?
Better get from sulphide.
Got it.
For example, our mine in Manitoba would go to production, which is nickel sulphide. It would be 97% less carbon emission than a mine from laterite in Indonesia. First of all, because the source of power, one is caught on a coal-fired power plant versus hydro, which is water. And secondly, is the power consumption is a lot less because we don't have to heat. There's no burning, whereas the other guy is heated up to 1,000 degrees. So these are the major differences, and that's why you're seeing. And third is the environment as well. Our tailings, as I referenced to you, we have a FLYN. We find some geographical, like we find a valley of which we can manage that tailing. Whereas the tailing is a lot more problematic because they use very high acid to dissolve the ore, of which they're dumping into the tailing and dump that tailing directly into the ocean. So I think there's no better way to. The EV manufacturers are actually shooting themselves in the foot if they were to procure nickel from laterite. And I'm sure Elon would have mandated Vale to keep getting that nickel from sulphide and not from laterite, of which Vale do have projects in Madagascar and elsewhere that's coming from laterite. So, and I think that's going to be very big, very clear. Once you get that nutritional table, you're going to see exactly the car you're buying where the nickel is going to come from. There's definitely a very conservative effort to try to go green there. Yes, Dylan?
John, where can our audience find you, find your company, and stay in tune with all of these, updated insights on what's going on in the nickel space?
Well, I think, Dylan, if you look at looking at the common denominator and looking at the EV space, it's a very competitive space. If you're looking to invest in EV space, it may pay to look at their common denominator, which is nickel, because it's getting very, very competitive with BYD. I think you read yesterday that's exceeding the Tesla volume, yet to be verified. So there's a lot of nickel, and if you look at the common denominator, I think nickel is one of the better bets because lithium, there's abundant lithium, and I think nickel is going to be around for at least for the next 5 years before the advent of its replacements. And that's validated by the auto manufacturers and battery guys that we're talking to that are asking for nickel 5 years from today. And there's a lot of information like a Nickel Institute. But if you like to know my outlook on nickel and so just my general thoughts, I'm pretty active on Twitter. So you can look up John Lee Battery Metals. So that is my handle. Or if you can go to flynickel.com to learn a bit more about our company. And we do have a lot of information, such as a technical study that outlines the different cost, CapEx and OpEx, and so you get a bit of an idea on sort of the process of we have lots of documents and hundreds of pages. For our guys are sort of they are just trying to get introduced to nickel for the first time. So the website is flynickel.com, and my handle is John Lee at Battery Metals on Twitter. And finally, just we're actually listed company on the Toronto Stock Exchange. It's FLYN. And then on the OTC, that's FLYNF.
Okay, beautiful. I will put all of that in the description below so everyone watching can go find that. And John, honestly, thank you very much for taking the time to talk. I have honestly learned a lot, so this has been super helpful.
Dylan, it's my pleasure, and I appreciate the invitation.